What does it really mean for an AI to think? Today, we're diving deep into programming fundamentals, the strategic substrate. Beneath every application, every service, every cloud deployment lies a set of fundamental principles. Data structures, control flow, state management, abstraction, these are not academic relics. They are the load-bearing walls of all software. As systems grow, minute fundamental flaws multiply into cascading failures. In the age of AI-generated code, deep fundamental literacy is the single greatest risk mitigant. The difference between a fragile system and an antifragile one is the strength of its fundamentals. This is the silent compiler of civilization. But here's where it gets interesting. We learn words, not thoughts. Developers internalize syntax, APIs, and framework incantations, but lack computational reasoning. Code works by coincidence until it doesn't, and then shallow mental models collapse. The gap between writing code and understanding computation is widening with every abstraction layer added. When a production system fails, the root cause is almost never a missing semicolon. It's a missing fundamental model. Existing education and onboarding focus on doing, not understanding. This is the syntax trap. So what's the real problem? Let's talk about abstractions hide reality. Modern languages and frameworks bury state, flow, and memory behind elegant interfaces. Developers assemble components from libraries without internalizing the underlying principles. Mental models become shallow. What you can't see, you can't reason about. When abstractions leak, and they always do, the unprepared engineer is lost. The illusion of simplicity creates systemic fragility. The cause. We mistake interface familiarity for true understanding. This raises a critical question: make computation visible. Introducing Axiom, a unified visual grammar of programming fundamentals. 5 universal primitives: data, transformation, control, composition, abstraction. Every computational construct reduces to these core shapes. Axiom renders invisible processes as spatial structures you can see, manipulate, and verify. It's not a diagramming tool, it's a mental operating system. From syntax recall to systemic reasoning. The breakthrough: a visual language that compiles directly to deep understanding. A new lens for engineering. Now let's zoom in on layered mental OS. Axiom organizes fundamentals into 3 composable layers. Primitive layer: data, state, flow, the atomic particles of computation. Pattern layer: recursion, iteration, reduction. Divide and conquer reusable structural blueprints. Principal layer: modularity, invariance, abstraction, composition, the architectural laws. Each layer builds on the one below, forming a rigorous thinking framework. Learn once, apply everywhere. From concrete primitives to abstract principles, Axiom provides a complete mental model stack, a composable, layered architecture for the mind. Here's something most people overlook. Data has shape. State has time. Data: structured containers, lists, trees, maps, sets. State: a timeline of values with mutation, immutability, and ownership. Visual contracts: every data structure is a shape. Every state transition is a directed arrow. Immutability becomes a spatial constraint. Shared state becomes a visible hazard. The silent backbone of all logic, now explicitly visible. Understand the shape of your data, and you understand the behavior. Data is not abstract. It has a geometry. Think about this for a second. Flow is a directed graph. Conditionals fork, loop cycle, recursion unwinds. All control structures are graph topologies, not scattered keywords. Axiom visualizes execution flow as a navigable map. Nodes are states, edges are transitions. Branch prediction becomes path analysis. Loop invariants become cycle properties. Concurrency is a fork-join structure, parallelism a scatter-gather. Control is no longer magic, it's geometry. Every conditional, every loop, every recursive call mapped to a tangible shape. The result, execution reasoning without mental simulation. And this is where things get complex. Build complex from simple. Functions are transformations composed into pipelines. Abstraction creates boundaries with explicit contracts, inputs, outputs, invariants, encapsulation, parameterization, and layering becomes spatial arrangements in the visual grammar. Composing functions is connecting boxes. Higher order functions are nested structures. Modularity is a partition of the visual workspace. Coupling is proximity. The entire system architecture becomes visible as a composition graph. Abstraction is no longer a vague concept, it's a visible boundary. Axiom makes structure tangible. But here's where it gets interesting. Deconstruct, map, compose, verify. A systematic four-stage workflow from problem to verified solution. Deconstruct, break the problem into fundamental computational primitives. Map, assign each primitive to its axiom visual pattern, data shape, flow graph, etc. Compose, connect the visual components into a coherent topology. Verify, check invariants along edges and nodes, ensure contracts hold. The method is repeatable across domains, web, embedded, distributed systems, from ad hoc coding to disciplined engineering. Axiom transforms programming from trial and error to systematic construction. So what's the real problem? Let's talk about every problem is a known shape. With Axiom, common computational problems reveal their fundamental structure. Sorting, a reduction tree. Search, a traversal graph. Concurrency, a fork-join network. Caching, a state management diagram. API design, a composition of transformations. Recognize the pattern, and the solution is a template you adapt, not invent. This accelerates design, reduces bugs, and makes systems predictable. The Axiom library of fundamental patterns becomes a shared vocabulary across teams. Problems become instances of patterns, not unique puzzles. This raises a critical question: defects plunge, velocity soars. Teams applying Axiom fundamentals report transformative results. 60% fewer production incidents, rooted in deep invariant understanding. 40% faster code reviews. Reviewers assess contracts, not style. AI-generated code validated against fundamental models, catching hallucinations. Onboarding time halved. New engineers learn the visual grammar, not tribal syntax. Fundamentals are the ultimate performance multiplier. Measured across thousands of engineers, the shift is dramatic and durable. This is the return on fundamental fluency. Now let's zoom in on a universal notation for computation. Axiom will embed natively into IDEs, documentation, and AI coding assistants. Engineers will sketch programs as visual compositions, then generate code. The notation becomes the lingua franca for system design, code review, and education. Every new developer learns the 5 primitives first, building a rock-solid mental foundation. The era of fundamental first engineering, where understanding precedes implementation. This isn't a tool, it's the next layer of abstraction for the industry. Axiom, the visual operating system for software thought.